Then you say, okay, this is x minus 2 if x is greater or equal to 2. And it's minus x plus 2 if x is less than 2. So you come back here and say, okay. So it means I'll have to break my integral from 0 to 2. Here, I'm integrating negative x plus 2 dx plus, you run from 2 to 4. Of the same function, you're now integrating the top piece, x minus 2 dx. Because that's where the function is, that's how the function is defined in those pieces. This gives us negative x squared over 2 plus 2x from 0 to 2 plus x squared over 2 minus 2x from 2 to 4. Then you substitute. So you have 4 over 2 plus negative 2 plus 4 minus 0 plus 4 squared, that's 16 divided by 2, we get 8 minus 8 minus 2 there, I get 4 over 2, that's 2, and then plus 4. So we get negative 2 here, and this they go. Then this they go. So the answer is going to be 4. What is key is knowing how to redefine the absolute. And then you look at the intervals. It is defined from 0 all the way up to 2 as x negative plus 2. It's defined from 2 all the way up to infinite as x minus 2. So if you look at your limits, you have 0 to 4. 0 to 4. 0 to 4 is being shared here. You move 0 to 2. And this is from negative infinity. This one. From negative infinity. So you move from negative infinity. Within negative infinity, you have 0 somewhere up to 2. And then you end, then you pick it up from 2 up to 4 in the other function.
All right, thank you.
Okay, integral. The integral of another integral question today is just integration, guys. Don't want to graph the power half the x. Here we use by parts. Now we have algebra. It's all algebra. So when you're on laity, if you're having the same thing, break the same thing and do u dv. So what will be u? We'll go back after some time. So you let u be x, and then your dv will be x plus 1 to the power half dx. Wow, what do? You differentiate u. You get 1 multiplied by dx. You integrate dv. You integrate this guy, x plus 1. You add the 1 to the power, you get 3 over 2, and then divide by 3 over 2. We may wish to write it as 2 over 3, and then x plus 1 to the power 3 over 2. Like that. That is v. The integral says If I have this, I need to multiply UV. So we'll have 2 over 3x, x plus 1 to the power 3 over 2, minus V du. So we'll have 2 over 3, the integral of x plus 1, 3 over 2, dx. So we're almost done. Let's just integrate again. Minus 2 over 3. And then when we integrate this, it will be x plus 1. To the power, we are adding a 1 now. So we get 5 over 3 divided by 5 over 3 plus a constant c. So we have derived this x plus 1 here. Simply because its derivative is 1. If it was x squared inside, we would have had serious issues on how to integrate it. But now, because the derivative of x plus 1 is 1, so we're assuming that we're using substitution here. So we're not talking about it. It's just a byword thing. So we do that. Okay. So we decorate 2 over 3, x plus 1, 3 over 2, minus, you flip, you get 2 over 5, x plus 1, 5 over 3, plus c. It's the integral by parts. Spending our time on by parts today. Okay. Another question is significance. Hello.
If we're flipping, like if we take the 5 over 3 on top, doesn't it become 3 over 5 times that whole thing?
It does. It becomes 3 over 5 times 2 over 3. So the 3's will cancel.
Yeah.
Well, the screenshot is here. Let's just say I want to get a screenshot. I have a screenshot. Isn't 5 over 3 supposed to be 5 over 2? I don't know. Let's check. How did it become 5 over 3? Yeah, you're right. It's supposed to be 5 over 2. Here. I don't know where I got the 3. So it's 5 over 2. 5 over 2. So here, things will change then. We'll have this 2 over 5 multiplied by 2 over 3. Thank you so much. So our answer is going to be wrong. 3 over 2 minus, so it will be 4 over 15, x plus 1, 5 over 2. Yeah. Yes. Good. Okay. Another one. What other integrals now? Of good interest here. Okay, 3. Evaluate. Zero to 2 of f of x dx, where f of x is equal to 2x squared. If 0 is less or equal to x, less or equal to 1, and 3 minus 1 over x. If 1 is less or equal to, if 1 is less than x, less or equal to 2. There's nothing. Don't call it the binomial, call it the algebra. We don't have binomial in integration. So integrate f of x from 0 to 2 if f of x is defined in that way. So as you can see, f of x has 2 pieces, from 0 to 1 and from 1 to 2. So we'll break our integral. We'll run from 0 to 1 and pick the one on top, 2x squared dx. Plus, we'll run from 1 to 2, integrate f of x, that is 3 minus 1 over x dx. Then integrate. So we'll have 2x power 3 over 3 from 0 to 1 plus 3x minus ln x from 1 to 2. Yeah. That is, you substitute 1, we get 2 over 3 plus 5 is minus 0 and you substitute 0. Okay, let me put it so I don't say where has it gone. Minus 0 when you substitute where there's x there. Plus substitute 2, we get 6 minus ln 2 minus substitute 1, you get 3 minus ln 1. Ln 1 is 0. So we have 2 over 3. 6 minus 3, that's 3. So we have 3 and then minus ln 2. Because ln 1 is 0. Where is 3x coming from? We're integrating 3. When you integrate 3, you get 3x. So here we get 3 common denominator. So we've got 2 plus 9, that's 11. Over 3 minus 8. That's an integral of the function. Very nice question. Okay. Another one. Hello.
Kindly explain or highlight more on how you already define the function there.
We haven't redefined. This was the question. The piecewise. Integrate f if f is that. defined as it is in the question. The job is to pick according to the limits. So you pick from 0 to 1, you pick 2x squared. From 1 to 2, you pick 3 minus 1 over x. Okay. Another one. Where now is hello?
Before you proceed, how do you replace the values of x there?
Ask the
Check
question
how
again.
do you know that here I have replaced this? How do you replace the x with the 1, 2, or 0? How do you know that here I have replaced the value of x with 0, 2, or 1?
Why is it still linked? Because you don't know the value of them. So leave it as linked. How do you replace 1, 0, 2, 1? We have said the function is 2x squared if x is between 0 and 1. So we're integrating from 0 to 1, the function 2x squared. So when I integrate it, I get this. So I substitute the limits. I start by substituting 1, then I get 2 over 3, minus I substitute 0. I get 0. Plus, so I'm done with the first part. I move the second part. I substitute 2, where there's x and where there's x here. So I get 6 minus ln 2. Then minus, I now substitute 1. I put 1 here, I get 3. I put 1 here, I get ln 1. But ln 1 is 0. So it becomes easy for me to simplify. 6 minus 3 is 3. Then you do the addition. Okay. Maybe we can do one more. So we ask 1 minus x to the power 3 over 2. The power 4 multiplied by root x dx. What's the integral of this guy? What do you use then? Substitution, right? You let u be 1 minus x to the power 3 over 2. Then differentiate it. We'll get 3 over 2 x to the minus 3 over 2 x to the power half. Because you're doing minus 1 there. But this can be written as minus 3 over 2 root x. Super. Dx. Then you solve for dx. So you divide minus 3 over 2 root x if you want. Divide minus 3 over 2 root x if you want. So dx is equal to du over minus 3 over 2 root x. Then you go back and substitute. So now we have the integral of u to the power 4 root x. Dx is du over minus 3 over 2 root x. So this root x and this one will cancel. What do we remain with? We can take this guy outside as minus 2 over 3. Then integral of u4 du. So we get minus 2 over 3.
That one, I thought it's supposed to be negative 3 over 2. You've written 2 over 3.
Yeah, so because it's in the denominator, so I can flip it.
Oh, okay.
Yeah, so it will become 3. So u5 over 5 plus c. So what is u? So now we have negative 2 over 15. U is 1 minus x 3 over 2 to the power 5 plus the constant c. So today I've talked more of integration because of what I'm seeing. You struggled integrating those questions I gave you. What else was the challenge? Let me talk about one thing. In the last 10 minutes, let me talk about this thing. I'll call them examples. 1, evaluate A, the limit as x goes to 2, x squared minus 4 over x3 minus 8. If when you substitute the number 2, if we substitute 2, we'll have 0 over 0. If you get 0 over 0, if you try to factorize, you get the solution. But I've seen that we are messing up when it comes to factorization. So maybe let's do this. Let's use Hopital's rule. What does it say? You differentiate the numerator. So you differentiate x squared, you get 2x. You differentiate 4, you get 0. Over, you differentiate x power 3, you get 3x squared. You differentiate 8, you get 0. Then now you substitute 2. So we have 2 by 2 over 3 by 2 squared. 2 by 2 is 4 over 3 by 4. So this cuts, then you get 1 over 3. This is the shortcut. As compared to the limit as x goes to 2, then you factorize, you get x minus 2, and then you get x plus 2. Then for the denominator, because it's a polynomial, you use synthetic. So you have 1, 0, 0, make 8. And then you drop the 1, 2, 2, 4, 4, and then 8, 0. So you will say x minus 2 multiplied by x squared plus 2x plus 4. So this and this cuts. Then substitute 2, you get 4 over 4, 4, 4. 12. So you get 1 over 3. Listen. So many of you, those who went for factorization, what I was saying is you are messing up on the factorization of x3 minus 8. I don't know why it's a big issue. So try just differentiate the numerator. This works also for, it also works for this. It also works for this. To x. It works for this also. If you substitute infinity, infinity, you have infinite over infinite. So what do? You differentiate. You differentiate, you get 9x squared. You also differentiate down, you get minus 2 minus 9x squared. If you substitute, you have infinite over infinite. So you do again. You get 18x over minus 18x. You can now divide. You get the limit as x goes to infinity of -1, which is equal to -1. Smart, easy. Smart, easy. The limit as x goes to 0 of tan 5x over x. Tan 0 is 0, 0. So what do? You differentiate. The limit as x goes to 0, you differentiate tan, you get 5, 6 squared 5x. You differentiate x down, you get 1. Then you substitute where there's x, you take 0. So we have 5 sec 5 by 0 or 6 squared, we square it. But sec 0 is 1. So we get 5 multiplied by 1, which is 5. We suffer doing the test. You suffer there. Woo. You are writing things that are hard to understand. We are hoping that you, the owners, understand them. So tomorrow, we are back at the past paper. I think the part of the past paper remaining, that one we are doing, is not too nice, but we'll finish it because we have like the part of matrices, the integral question which was there already did it. So that's why they specialize on the integral just. So today we're ending here. Pick it up
So I
tomorrow.
wanted to ask if we're going to have another test, another practice exam.
We're having one on Wednesday. The
Thank
one we are having on Wednesday. The ones we're having now, the remaining ones, are very closer to the thing. So we have to do them nicely at night, not during the day. So start well, and when you sleep, good night.